We will proceed with the discussion, however. In case of dynamics, in which under 10th class portion, we will be predominantly studying only rotatory motion and the dynamics thereof. We begin with the angular displacement of a body. Now, since it is only like a revision class, I will really run through the revision. Angular displacement means displacement in terms of angle. That is why it is called as angular displacement. So the angle through which the radius vector rotates is called as angular displacement. So this is what I was asking. You see, there is a r here, there is a theta here. Why do we use r's and thetas in rotatory motion? Why is it that we don't use x and y? Yes, one particular school has written that r is radius and theta is the angle. Yes, I do know that r is radius and theta is the angle. The question was, why this? Why not x and y? If you have gone through the recorded sessions that we have given you, you would have come across an animation where I had shown a body going around in a circular path. And at every point, I had indicated the x and y coordinate of the body. For example, if you take a quick review of that, suppose this is the y-axis and this is the x-axis, and the body is following a circular path like this, right? Of course, I'm using a digital pen here, so it is a bit slippery, but what is more important is the physics here. Fine. So this is x coordinate and this is the y coordinate, or this is the x-axis and this is the y-axis. When the body is anywhere here, you see that x is positive and y is also positive. When the body is here, you see that x is negative and y is positive. Y is positive. When the body is here, x is negative and y is also negative. And when the body is here, x is positive and y is negative. This is how complicated the motion becomes. Positives and negatives and all that. That is one issue. There is a second issue also. As the body moves like this, the x coordinate decreases and the y coordinate increases. Then as it goes towards the negative x-axis, y coordinate decreases and x coordinate increases. So there are two things which are varying, and they are varying with reasonable complexity. So it is very difficult to attack the problem from that end, right? Therefore, I'll just clear the annotations. Right. Therefore, instead of going to x and y coordinate system, we use r and theta. Now, when the body is moving along a circular path, first thing that remains constant is the radius, because the radius cannot change. There is a well-defined circular path. So what can change is only the angle. Therefore, it is more easy to understand the movement of a body in terms of displacement, which is represented in terms of angle. Therefore, very simply, it is called as angular displacement. That is displacement in terms of the angle. Therefore, angular displacement is final position minus initial position, again in terms of angle, and its SI unit is radian. It means here we could say that the body is initially, it was making an angle of 30 degrees, or the radius vector was making an angle of 30 degrees. From there, it went to, let us say, 62 degrees. So this angular displacement is now 32 degrees. It is now 32 degrees. This displacement in terms of angle is what is called as angular displacement. Now, when there is angular displacement, there will be some time taken by the body to move. So using angular displacement, you can define angular velocity also, just on the same lines that we did in kinematics. In kinematics, velocity was displacement by time. Here it is angular velocity, therefore angular displacement by time. It is as simple as that. Therefore, omega, that is the notation for angular velocity, is angular displacement by time interval. Time interval means time taken by the body to start from point A and to reach at point B. Therefore, here I can write angular displacement is θ2 minus θ1, that is final minus initial. Time interval is t2 minus t1, that is also final time minus the initial time or the starting time. Therefore, angular velocity is given by rate of change of angle with respect to time. Therefore, θ2 minus θ1 by t2 minus t1, which can also be written as delta theta by delta t. Now, since you students are in 10th class, I would like to assume that you know what that delta symbol stands for. The delta symbol stands for a small amount of change. Right? There are many new schools which have joined in. So let me just take a look at that. Scholars Model School has joined in. Vani Niketan has joined in. St. Paul's, Vishwodaya. Right? Okay, there are so many schools that have joined in. I hope all of you are getting your mics and cameras in place. Fine. So we have defined angular displacement and then we have proceeded to angular velocity. Then there is something called as instantaneous angular velocity. It means angular velocity at a particular instant of time. Now, when is this one required? This is required in situations like this. Suppose you switch on a fan. Would it immediately start rotating at a very high speed? It won't do that, right? Gradually it starts like this and it picks up speed and it picks up speed and finally it starts rotating at one particular speed. That is the angular speed. That's what we speak of. So while it is increasing its angular speed or angular velocity, what is the velocity after 1.3 seconds that I started the fan? We should be in a position to calculate that. That velocity at that particular instant of time is called as instantaneous velocity. The word instantaneous is very frequently used in physics. You say instantaneous force. It means what is the force that is being applied right now. Or you say instantaneous displacement. What is the displacement right now? Or instantaneous velocity. What is the velocity right now? So instantaneous means at that particular instant of time. It is as simple as that. In physics, almost all the terms are self-explanatory. If you know a bit of English, you will be able to relate to the terms easily. So angular velocity was given by delta theta by delta t. Instantaneous angular velocity means that the time interval that you are taking in the denominator, you try to make it as small as possible. Therefore, I have written here limit delta t tends to 0. It is not equal to 0. It tends to 0. Your mathematics teachers will tell you what is the difference between being equal to 0 and tending to 0. Right? Therefore, when the time interval tends to 0, it means the time interval is very, very, very small. Right? Then the small time interval, instead of writing it as delta t, we write it as dt. So delta t is time interval, dt is also time interval. Delta theta is angle interval or the displacement in terms of angle. D theta is also displacement in terms of angle. The only difference is that these delta things can be very large, whereas dt means very, very small. That is what is called as angular velocity. Now, what will be the unit of angular velocity? In the numerator, you see that angular displacement is in radians. Denominator, it is time, therefore it is in seconds. Therefore, it is radians per second. And when you bring it to numerator, you write it as radians or rads to the power of -1. Here, I would like to make one more important observation. In your lower classes, like in 9th class or in 8th class, you might have come across chapters on measurement. There we learn that the unit of length is meter, m. Unit of mass is kilogram, kg. And the unit of time is second, which is to be represented as s. Even after learning that, I see that most of the students write second as SEC. That is wrong. And if you are aiming for a cent percentage in 10th class, these are the small things that play a very important role. Suppose you have written a paper in a very outstanding manner, everything is correct. And suppose another person has also written it equally correct. Now suppose there is a tie as to who has to be given 100 out of 100 in this. And 100 out of 100 or 60 out of 60, whatever is the maximum mark in the paper. Then the invigilators or then the people who are correcting the papers will see if there is any mistake. And there if you write radian SEC to the power of -1, they'll cross off and cut off one mark there. Because SEC is not recognized unit in SI. Only S for second, S to the power of -1 because it is second inverse. Right? Make a note of that and all of you make sure that you follow the proper units. And while I'm showing all this to you, if you want, you can write down all this in your notebooks. I'll not give you time for you to write this down because this is a very concise summary of the chapter. It is just like a quick notes for reference at the, just one day before the exam also. Okay, then this instantaneous angular velocity, the SI unit of angular velocity is radians per second. Another common used unit of angular velocity, whether it is instantaneous angular velocity or angular velocity, any angular velocity is RPM. It means rotations per minute, or in some cases, it can also be called as revolutions per minute. Because rotations and revolutions are just two subsections of what is broadly classified as a circular motion. Therefore, there should be a method to convert from RPM to radians per second because RPM is rotations per minute, but minute is not an SI unit. Seconds is an SI unit and rotations is not SI unit. Radians for angle is an SI unit. So how do we do that? One rotation per minute. We write it like numerator and denominator. Each rotation means 360 degrees. 360 degrees means 2 pi radians. Therefore, we write 1 into 2 pi by 1 minute is 60 seconds. And if we cancel the common factor out there, you get pi by 30 radians per second. So whenever you have to convert RPM to radians per second, you can multiply it by pi by 30 and you can convert it to radians per second.